Now this video is about charging electric unicycles, but not like this, I don't think. Well, what have we got here? Well, this is a benchy, and I am 3D printing a benchy. It's like a little boat. It's a calibration piece for 3D printers actually. So I'm printing this, and I'm printing it in where are we? Material TPU 95A TPU, which is a soft rubbery material. Now the reason I'm printing in TPU is I'm printing rubber buffers for my Roger charger. So here it is, the benchy printing on my 3D printer. Now I've had to do some modifications to my 3D printer. Well, I didn't have to really, but for the best chance of getting a good result. The boat's in there, you probably can't see it at the moment. So the first thing I've done is I'm not printing on the usual EI bed. I'm using Garolite, which is printed circuit board, effectively fiberglass printed circuit board. Garolite's very good for printing TPU on. The bed's at 40 degrees C. I'm printing TPU at 220 degrees C. Now the other modification I've done to the printer is this. This is a food cake Tupperware type box, and one of the things with TPU is it's hygroscopic, so it absorbs water, and that makes the filament splutter as it comes out of the nozzle and you get a bad print. So it's in there to stop it absorbing water. This printer's a Kiddie X Plus, and they do boxes like this, but they cost a fortune. So this was a homemade thing, and I think it's better than the Kiddie one myself, but there you go. So it's like a cake box. There's some bits inside there to center the spool, and it just goes on the back. Now the other problem with TPU being soft and rubbery is it doesn't go through this PTFE tube very well over long distances. So it's better to have the spool really close to the extruder, so it's coming through here and going straight to extruder, so it's not pulling on the extruder. So at the moment, this is the first print I've done using this arrangement, and it seems to be working very well. So once this is finished printing, we'll examine the benchy to see if it's a good print, and if it is, the next print will be the rubber buffers for the charger, for the Roger charger, which is a high capacity charger, for my Begode Master. So what else have we got here? I thought I'd show in. This is another 3D print I've done. That's in ABS plastic. ABS plastic is the same sort of plastic they use for Lego and car parts and things, but I'm made in, so it's quite nice. But anyway, so that's it for the minute. Thank you very much. Well, I'm 3D printing the front rubber bumper for my Roger charger, the fast charger for my Begode. Well, I'm using it for my Begode Master. So we'll go and see how the print's doing. So, like I said before, I've had to do a little modification here, because this filament, this TPU filament, is hygroscopic, which means absorbs water. So I've come up with this Tupperware type cake box to stop it absorbing moisture. Now if the print was short, it wouldn't matter, but this print is, what are we, 12 hours. So so here's the item, and this is what it was printed so far. Let's have a look here, see if we can see it. So I'm printing it onto Garolite, which is printed circuit board. They call it FR4 or FP4? FR4 I think they call it. But it's Garolite, fiberglass, printed circuit board. TPU will stick to anything long, but this Garolite's quite good. It's got a smooth surface and it should give quite a reasonable finish. So yeah, so that's printing away. Previous to printing that, I intend to print a test piece, and this is that going to focus? I don't know. That's called a benchy, and it's you can see it. It's all rubbery. It's done in TPU. Benchy came out very well, better than I expected actually. There's a little problem here. I've enclosed, there's only 2 layers this is, so I've made 3 layers on this new part that I'm doing, but except for that it printed pretty much perfect. It bridged the windows, even the funnel here didn't melt and go to a blob. It's a tiny little hole in the bottom here, which disappears if it doesn't print properly. Sometimes this feature here gets all melted and horrible if it doesn't print properly, and it printed perfectly. I can even see the legend on the bottom, GT30XYZ, written on the bottom. So yeah, very, very happy with the test print. Came out very well. I'm not used to rubbery filaments. This is all kind of squeezy, so it's quite fun. So yeah, so all good. So we'll leave that printing. I've got to print the rubber bumper for the back of the charger as well. That's probably another 12-hour print, I should think. But yeah, jobs are good. Okay, so I did a video before where I just showed you printing parts for my Roger charger, which is a fast charger for the Begode Master. What I didn't do is show you the finished product, so that's what we're going to do now. This is the Roger charger. I actually bought this one from AliExpress, and you can see on the ends I've got my 3D printed bumpers. One on the front and one on the rear. Now this charger can charge all my wheels. Well, it can't charge the 9-volt 1E Plus at the moment, but it can certainly charge the Kingsong wheels and the Begode wheels, and it can charge them quickly. Anything up to 15 amps. Now my Begode Master, it's a 50 Master, I wouldn't charge that beyond 9 amps, and probably much the same for the 16X that I've got, and the S18 I might charge that a bit less as well, maybe 5 amps. Yeah, so that came out very well. This just protects it. When I'm taking it anywhere, I've got a case, so that goes in the case, and then I can put that in a backpack and take it with me if I needed to charge quickly on the road. Now, in addition to the charger, we've got a lead with the connector for the Begode Master, and then I've made up adapters here. This is for the Kingsong. There's another one for Kingsong. So sorry, those are actually the Kingsong, Begode Kingsong. That is actually adapted. It's got a 3-pin output. This is an adapter so the charger can charge the batteries on the Begode Master independently. I mean, I'd only charge them at 67 volts if I was to do that, but if I want to balance them up manually and charge them separately, I can do that with this adapter. And then finally, which was the subject of another video, this is my battery monitor. So when I'm charging any of the wheels, I can see exactly what charge I'm putting into them. But anyway, I thought I would include this just to show you the kind of extra bits and pieces I've done in regarding charging my wheels. Keeping an eye on your batteries, knowing what's happening with the batteries on your wheels is an important consideration with EUCs. You know, there has been some disasters with fires and problems and packs failing, and so if there's anything going wrong with your batteries, you want to be aware of that as soon as possible. So in combination with EUC World, which I'm going to do another video that shows you some monitoring in charging you can do with EUC World, but with the charge monitor, I can see as I'm charging the wheel how much energy is going into the wheel, how the voltage is increasing, the time I'm charging, and you get a feel for what is normal for your battery pack when you're charging the wheels. So if anything starts to be different from that, if you start seeing unusual behaviour in the information that you're getting as you charge the wheel, that you've got an indication that something is going wrong, unlike if you just plug your OEM charger in, really you can still do some battery monitoring in a sense, but really all you're really doing is the time it takes you to charge and whether that's consistent with what you thought, and your charging light on the charger that it goes out at the top of the charge when the batteries are complete. So that is far more limited information than what is possible if you were to build a charge monitor or do monitoring via EUC World. So I just like playing these things anyway. It's electronics is a bit of a hobby with me, so well, it's my job, and it's also a hobby. So apart from the riding, I also enjoy doing these other aspects of the hobby in much the same way as people modify their wheels. You know, they put pads and handles and lights and all sorts of things on them. I mean, I do a bit of that as well. Well, I'm here charging my Begode Master 50 cells. Now I've got EUC World working on the mobile, so in order on a Begode wheel, in order for it to be talking to the wheel, I have to switch the wheel on. So the wheel switched on, it's not balancing because it's leaning back on its stand, but the wheel is on, and it's charging with the standard Begode 3-amp charger, and then that is running to my charge monitor, which I made before. I've done a video about that, and that's charging the wheel. Now, in addition to that, I've got this TPU link thing, that's feeding mains power to the charger. Now, what's happening here is EUC World is controlling the charge and monitoring the charge. So when the wheel is completely charged up to 134.4 volts after an hour, because I've set that on the app as well to give it a chance to do some balancing, EUC World will turn off the TP link, therefore turning off the charger. So EUC World is telling me the voltage I'm charging at, or the battery voltage actually, is 118.7 on here. Here's the mains voltage. In the UK we're supposed to be 240, but it's actually 245.4 volts, and that's consistent what I measured with the meter, so we're a little bit higher here. Here's the charging power, we're charging at 400 watts. Here's the amount of watt hours I've put into the battery so far, which is 113 watt hours. Here is the charging current. It's a 3 amp charger, but it claims to be charging at 3.4 amps. Here's the mains current of the main supply that I'm drawing. It's almost 3 amps. This is power factor. This is in capacitive or inductive loads. There's a discrepancy between the phase on the mains of the incoming voltage and the incoming current. So you'd expect the maximum current to be at the maximum voltage and the minimum current to be at the minimum voltage, but in the sine wave, if those things are slightly out of phase, which is caused by having inductive or capacitive load, you get a power factor. So this is telling me the power factor. And here's the duration I've been charging the wheel up for 16 minutes. At the bottom here it also gives you a graph, so you can see from there up to now, there's time along the bottom, and you've got 2 lines. You've got the voltage stepping up in blue from where I started, which is 116 volts, and up to 119 now, and the current, which is a constant, the red line across the top, which is the 3 amps. Now, so I've got all that information here, and control, because it switches off when it's finished, but the whole thing effectively is duplicated because of my charge monitor here. Now, I don't think you can see the displays, but I'll read them off. It's telling me the battery's 122 volts instead of 119 that EUC World is telling me. It's telling me I'm charging at 3.2 amps. EUC World is saying 3.4. It's telling me I'm charging at power 394 watts instead of 434 EUC World is saying. It's telling me I've put this is so we tend to term in terms of watt hour our batteries. I mean, the Begode mode's got 2,400 watt hour, and I put 394 watt hour into the battery. But there's another way of measuring the capacity of battery, which is more common in car batteries, is amp hour. How many amps equivalent, how many amps have you put in for an hour? And I've put in 1.17. So that's not really very relevant to us. For different voltage wheels that's going to vary, but if you want it, it's there. And I've been charging for 20 minutes here. So this is what my battery charge monitor is saying as compared with what EUC World is saying. So not a huge discrepancy, but it gives you a feeling of sort of what sort of accuracy we're measuring at. I think it's all good for Sebastian and the EUC World, but I suspect my battery charge monitor is the more accurate of the two, but I may be wrong. So that's it really. I just thought I'd just do this short video of my charging arrangements here. So I'm actually charging my Kingsong S18 at the moment, just with the standard charger, 1.5 amp charger, 84 volt. Is it 84 volt? Yeah, it's 84 volt. But I'm using my charge monitor. I don't know if that's going to bring up the display. Yeah, so we're 78.9 volts, 1.5 amp charging, 118 watts. We put 8 watt hour in. This is all down the left hand side, and then in amp hour, which is like you charge a car battery, you don't pay much attention to that, but I'll put 116 milliamp hour in there. The external resistance, that's irrelevant. and then the bottom one is I've been charging for 4 minutes. So in order to use my charge monitor, I'm using some adapter cables because I use this for the Begode, so I need adapter cables to convert to the Levino connectors that Kingsong use. Oh, pardon me. And the same on the other end. I've got an adapter down there to the Levino connector, and then that lead goes up and charging the Kingsong SAT. So that's it really.